So this is problem 4, practical kinematic 2. And the problem is shown on the finger. The bicyclist A traveling at 7 meters per second on the curve. So what does that mean? A is has the motion is curvilinear motion and increasing his speed at 0.5 meter per second square. So that is the tangential components of the acceleration and 0.57 meter per second square. And because it increasing speed, it means accelerating. So the direction of that tangential components of acceleration will be same at the direction of the motion, same at the velocity VA. So that is the A. And then move to the bicyclist B traveling 7.5 meter per second along a straight away. So it on straight line. So for the motion of B will be a rectilinear motion and increasing its speed at 0.7 meter per second square. So increasing again the acceleration of B will be the same at the motion and same at VB. So you see AB, same direction. If it deaccelerates, so opposite direction, as we solved in the previous problems. And then tangential components of A, it also A tangential components on the same at the direction of the motion. So with that, the question is determine the relative velocity and relative acceleration of A with respect to B. So there are two portions that we need to solve. The first is the relative velocity and the second one is relative acceleration. So let's start with the relative velocity. A with respect to B, so we have it so we have it V of A equal to V of B plus VB plus VA relative to B. VA relative to B. So from that, we can do the same as we do, draw the kinematics diagram. So the first one is A, as you can see on the finger, 7 meter per second and tangent to the path. So how we draw that tangent to the path? So VA and equal to 7 meter per second. What is the angle should be? What is the angle there should be? So let's look at here. So as you can see, this is VB. Sorry, VA. And then the angle here is we want to find out what is that angle compared to the horizontal axis, the X one. So as you can see, that one is tangential, so it will be a right angle. From that 40 degree, that have to be 50 degrees. So that one have to be 50 degree because two parallel lines. So here it will be 50 degrees. So that is a more challenge. You have to go to see the finger, looking for the concept of geometry, etc., so that you can make sure you find out the angles correctly. VB, that's simple. Go to the right, so we can write that VB and 8.5 meter per second plus VA relative to B. We don't know yet, so there are two components, VA relative to B, X VA relative to B, Y, and then what this we have done so for so many times. So you should be familiar by now. Go to problem 4. So from that we can do the scalar equation. So we have X and Y. So let X assume go to the right positive So we have VA cosine 50 degree. So write down VA 7 cosine 50 degree positive equal to positive 8.5 meter per second plus VA relative to B X. And this is one equation, one unknowns. So we have VA relative to B X equal to negative 4. What does that mean? It opposite to our assumption on the kinematic diagram when we assume it go to the right. Then now the answer should be go to the left. Meter per second go left. Okay, so that is the first components. And then similarly we can do with the y components of the relative velocity of A relative to B. So the first one going down, so it will be negative 7 sine 50 degree, and then equal to VB is horizontal, we project on the vertical, so it will be 0 plus VA relative to BY. Again, one equation, one unknown. I have VA relative to BY equal to also a negative number, negative 5.36. What does that mean? It will be 5.36 meter per second, opposite to our assumed direction going up, so negative, opposite direction going down. So that what you have for the two components. And now we want to know the magnitude and then the direction of the relative velocity A with respect to B, and do it very similar to what we did in the first three problems. So let's talk about A relative to B magnitude, so equal to square root of VABX, so 4 square plus 5.36 square, and that equal to 6.69 meter per second. So that is the first answer, the magnitude. And then the direction, we can always draw a big picture, 4 meter per second. This is x components, 4 meter per second, go to the left, and then 5.36 go down, 5.36 meter per second go down. So the diagonal of these rectangles, it will be the velocity A relative to B. So to find that angle, we can find the angle from the negative axis, theta there. Okay, so from that theta, as you can see, it will be theta equal to inverse tangent of opposite of theta, so it's 5.36 divided by 4, and the angle is equal to 53.3 degrees. So from that we can have the direction of this velocity, this relative velocity. So my answer can be what? What is your answer? VA relative to B equal to 6.69 meter per second at 53.3 degree. In this case, as you can see, counterclockwise, right? Counterclockwise from negative x axis. Okay, from negative x axis. So with that, we finish the first part of the solution. relative velocity of bicyclist A with respect to bicyclist B. And we go to the next video for to show how to solve the relative acceleration for this problem.